Now let's understand about this support vector concept. Okay, so suppose that if you are actually dealing with the data with the very high dimension, okay, and suppose you wanted to classify it, right, then you should probably approach towards this algorithm, which is like support vector classification, right? Now what it do is that if you just visualize this data, you will actually get it, because it is not very complex. Okay, so let's say that these are actually your data arrangement. Okay, this is your class A data and this is your class B data, and it's basically your three-dimensional plane. Okay, it can be 2D data as well. It depends upon your dimension of your data, right? Now let's understand about few terminology that what it is. Okay, so as you can see that, let's understand with 2D, right? So as you can see that this is my class A data and this is my class B data, right? So the plane that which is actually bypassing it, right, which is basically segregating these two classes of data, right? So this is basically named as your hyperplane. Okay, and these two line are basically the closest line to your closest data of particular class. Okay, so these things are basically called as support vector. Okay, and these are basically the outliers, right? Why it is outliers? Because the other class data is actually present in this current class, that is why it is known as the outliers. Okay, similarly if you see this part, so suppose your data is something looks like this, then you could basically like do it, right? So this is your hyperplane. Okay, and then this is your support vector, this is your support vector, because these are basically the closest line to this line, right? So this is actually, yeah, so this is basically my hyperplane, and this is by maximized margin. Okay, as you can see that, what is basically maximized margin? So maximized margin is basically margin in mathematics, it is called from the any plane. Okay, from the normal, if there is a normal, if you just draw the perpendicular to the origin, then the least distance is basically your margin, right? So this is basically your margin, and whichever having a very large margin, it means that it it has done the classification very well. Okay, so you have understood about the key points, right? What is support vector, what is like the maximum margin, okay, and what is hyperplane, okay, and what is like outliers in the classes, right? So again, what is support vector? So support vector model is try to find out the best boundary, which is like hyperplane, that separates the different classes with the maximum margin. So the intention of support vector is like it needs to separate the class A and class B or any classes of data, right, with the maximum margin is possible. Okay, and margin is what? It is basically distance between the boundary and the nearest data point, which is like your support vector. So the distance between two of the support vector is basically your margin, right? Then basically when to use the support vector, that is very very important, right? So when the data is not too large, right? If your data is not too large but your data is high dimensional, just understood it, that where will your data is having a very high dimensional, right? Suppose that if you're actually creating a face recognition algorithm, okay, in any of the face recognition model, right, which is the part of computer vision, right, you will see that the face embedding is basically not a one dimensional embedding, it's not a two dimensional embedding, it's a multi-dimensional embedding. If you're dealing with the text based data, it is actually multi-dimensional embedding, right? So similarly, if you're dealing with these kind of a data where the data set is not too large, right, but the dimension of data set is very high, right? So in this way you should actually use the support vector machine. Now there is one more point, just understand that what is kt is basically a kernel trick. Okay, so kernel trick is basically a mathematical function, right, which will try to increase the dimension of, let's say, 2D space to 3D space, from 3D space to 4D space, correct? So this is basically a kernel trick. So kernel trick is basically a function which looks something like this, so that if you pass any one dimensional data, okay, it is going to classify into the multi-dimensional vector. Okay, so that once your data is basically like organized into the multi-dimensional vector, it is basically easy for your hyperplane to divide the data. Okay, which is not very possible if the data set is very very concrete to a very low dimensional. So the more number of dimension you have, the better visibility you have. Okay, and there is a better comfortability for, let's say, hyperplane to basically segregate your data, right? So that is the like main motto of support vector, right? And then why actually the support vector is special? Okay, because it uses the support vector not all the data points, only the most critical points that define the boundary, correct? And it is very robust, it is a highly generalized ability, right? Because it's basically generalize your data into the multi-dimensional space, right, using the process called as kernel trick, right? then it is actually great on small to medium data set, right? Small to medium data set with high dimension. Okay, in the low dimension is okay, you can also like operate this classification algorithm, right? Now what is the meaning? So again, so if you see kernel, right? So kernel is basically, there are a lot of kernel, as I told you, right? Kernel is basically, there are a lot of kernel where you wanted to like use gamma is like, it's basically a kind of your hyperparameter, right? Which basically defines your decision boundary in the support vector. Okay, then similarly degree of the polynomial kernel. So in the kernel trick I have already show you, so these are basically a degree. So the more number of degree you have, so the more number of dimension you have where you wanted to generalize your model, right? So these things. Then again, types of support vector, just understood about types of support vector. So it has a linear support vector, you have a non-linear support vector. Linear support vector means, which means that your data is completely organized in a linear way. Okay, and non-linear support vector where your data is not very, like your data needs to organize into the non-linear way, which means that it needs a dimension. That is why you actually using the kernel trick. So kernel trick is basically a function, right? Which will like take your data and then just make this data scalable to their high dimensional figure space, so that it is basically easy for your hyperplane to derive the distinction between the different classes, right? So that is why. Then you have a polynomial, you have a sigmoid, and these are basically the kernels, right? What are the accuracy metrics? It's very common. So suppose if you're actually using the classification model, then the same accuracy matrices that I already told you in the previous lecture. So you have a precision, you have a recall, you have a F1 score, you have a AUC curve, you have a ROC curve. So these things will not going to change, right? Similarly for regression problem, so SVR means support vector regression. So it is basically used for regression classes as well. How? So let's say that if I wanted to find out a regression class, so the less number of margin I have, the better it is, right? And for a classification, the more number of margin I have, the better it is, right? So suppose if it is actually regression class, right? So the less number of margin I have, there is a better functionality, right? Because let's say this is my data, right? This is my arrangement of that data. So suppose this is my line, right? And suppose if this support vector and these are the support vector are very nearer to this line, so I would go with the support vector regression technique, right? I hope you get it, right? So basically, but more often it is used for classification, because no practitioners will definitely go or choose the support vector as a regression problem, right? It will rather choose the other regression like decision tree regression, XGBoost regression, linear regression, and other things, right? So yes, again, so if you just wanted to see this, let me show you again this part. Yeah, these things, right? So you have a support vector, you have a kernel trick. Okay, when to use support vector? Whenever you have a high dimensional, whenever you have a small to medium data set, the same thing, right? Whenever you have a clear decision boundary. Then what are the accuracy matrices? You have a precision, you have a ROC curve, you have a accuracy matrices, right? Then what are the kernel types? You have a RBF kernel, right? You have a linear kernel, you have a polynomial kernel, right? And what are the use case? Again, sentiment analysis, face recognition, where it needs a variety of dimension, right? Spam detection, it is a simple binary detection that you can actually use, right? Then this is the other part, like what is the key hyperparameter? So this is like C, kernel type, gamma curve control, right? We are actually controlling the curve in a kernel. So whenever you're actually using the kernel trick, so it is basically a gamma, you use gamma as a parameter, as a hyperparameter, right? You set it before, so that it can basically control the control the, let's say the curve, the nature of curve, right, in the very high dimension space. Okay, so yeah, the goal is to find out the best hyperplane, right? And what is the best hyperplane? Which having a very maximum margin. Okay, because the more margin I have, the better it is, right? And again, it is actually using the support vector to define the margin. So yeah, these things are just a different glossaries in order to make you understand and refresh about this topic, right? So I hope you get it, and any problem, just let me know.